Hello, this is the second video in this lecture series, Applied Statistics Using Programming. Today's lesson, we are going to be focusing on using R programming. So almost the entirety of this video is meant for someone who has never used R programming before, and we'll go from downloading R into all the basics of R programming. So sit back, get ready, and let's start. All right, so today's lesson, lesson 2, is the introduction to statistical software, specifically R programming. So first, you're going to need to download R. How do we download R? We can go to this website right here. So let's do this part together. This is what it should look like, rproject.org. Let's make it a little bigger. You'll see that there is usually a link right on the home page that says to download R. We can just simply click here, find which server is closest to you. Usually I'm in Korea, so that would be right here. But right now I'm actually in the US, so I'm going to find whichever one is closest to me here in the US. And I'm not really sure which one it is, but let's go with Carnegie Mellon. Okay, and now I can just choose which operating system I'm using. So if you're using Linux, you could choose the first one. Currently, I'm using a Mac. If you are using Windows, just click whichever one is right for you. If you click Windows, you can go over here and click Install R for the first time, if it's your first time. If you are on Mac, the options are a little bit different looking. If you come over here to this area, there is one on top for Apple Silicon. There's one on the bottom for older Macs, so depending on which version you have. So I would download this version here and then just go through the installer. I would recommend while you install R, here we go, to choose all of the basics, all of the default options. So here we go. Let's just continue. Sure, we can agree. You should probably read that, but I'm just going to install as it is. Okay, so the version of R will change over time. So for me, right now, the most recent version is a little less than 2 months ago as I record this. So is it important to have the newest version of R? For this course, it probably doesn't matter very much. So all of my coding for this course is pretty standard, basic R coding that doesn't really change much over time. However, if you were doing something a little bit more on the cutting edge, like using AI modeling, then I might recommend to make sure that you have the most recent release. But for this course, it probably doesn't matter which release you have, as long as you're somewhere in the 4 or 4.5 or later. Okay, so after you download R, I might also recommend to download RStudio. Many students prefer RStudio. Personally, I like to just use base R when I'm on a Mac, and I like to use RStudio when I'm on Windows. I just find the Windows management is a little bit easier using RStudio if you are on Windows, while on Mac I prefer a different version. Choose which version you like better. If you're just starting out, you might like RStudio a little bit better. It just kind of organizes things for you a little bit better. So let's take a look at RStudio. So if you just Google RStudio, you can find it. Okay, so how do we download it? Come down here, install R. We should have already installed R. If not, you can use this link here. If so, you can install RStudio. And we can see that RStudio requires version 3.6 or later. I think I just downloaded version 4.5. So anything after 3.6 is fine. You could download that here. I have already downloaded it. So when you download RStudio, just follow the instructions. I think you probably know how to download software like this. Okay, so after you've installed R, and optionally RStudio. RStudio is what we call an IDE. It's an integrated development environment. What does that mean? All it means is it is a program that lets you write R code. Now, I'm going to introduce base R and RStudio, and you can choose whichever one you like better. So this is the basic user interface for base R. You will have a script and a console. The console is where your code is running. It processes the code, and your script is easier to edit your code. In RStudio, it's organized like this by default. There are 4 sections. So on the top left is where your script is. On the bottom left is your console, where it runs the program that you've written. On the right, it will show you plots and other information that might be useful, such as packages, files. It's very common to use plots in this area down here. And on the top right, it gives you information about the environment. Basically, it means any objects that you're creating, any data that you're saving will be shown up in this top right corner. So for people who are new to programming, this RStudio interface gives you a little bit more information and always shows you that information in the same place, so it might be easier to get started using RStudio rather than basic R. Okay, so let's look at a code in both base R and RStudio. We can see some of the differences between the two. For this lecture series, you should be able to find all of the accompanying documents and code and PowerPoint presentations in the link below. Okay, so let's open that file, test drive of R programming. All right, so I've just opened the R console, not the file itself. I've just opened base R. And you'll see a file that looks like this, R console. Then it gives you a lot of information. First, it gives you the information of what version that you're using. The first is specifically the version number. Then it'll tell you when that version was released. And each one has kind of a silly name to help you know which version you're using. It makes it easier to compare versions. If I'm running great square root and you're running great square root, we know that we're using the same exact version number. Okay, so this silly name over here correlates with whichever version number it is. Okay, then there's some extra information down here, and way at the bottom we have what we call a prompt. You can see that it's a prompt because it's blinking when I click there. We also have a little arrow indicating this is where we could write our code. So I'm just going to write the code 1 + 1 and hit enter, and it gives me the result. This 1 here is telling me that this is the first result that is being output, and this is the result itself. So this is an index of which result I'm getting. This is the first result from this line of code, and this is the result. Okay. All right, so let's open that file. So I'm going to go up to File, Open Document. So after I go to File, Open Document, I just need to find the file that I want to open. In this case, it is called test drive of R programming.r. .r is what signifies that it's a R script. So I'm going to hit open, and boom, there is my script that I want to run. All right, so I can scroll up and down through my script, and I'm just going to arrange my script and my console in a way that makes it a little bit easier to read the script and the output in the console. So let's do that now. Okay, so as you can see, on top is my script. Here's the name of my script. On the bottom, it says R console. This is where my script runs. If I want to make my script bigger, I can hit Command+ on a Mac, or I can go up to Format, Font, and if I come over here, there's something that says Bigger. On a Mac, it says Command plus. It's showing me the shortcut that I can make my script bigger or smaller. You could go here and press that over and over, or use the keyboard shortcut. It's much easier. Once my script and my console are the desired size that I want them to be, now we can run our code. So to run my script, I can highlight the lines that I want to run and go to Command Enter. And it will run that script down in my console, and it will show me my result, right? All right, so another thing we can do is just using the up and down arrows, you can see that we have a mild highlight. You see like this gray bar is showing me which line of code is being highlighted. If I hit Enter on that line of code, it will run that line of code. If I go down here, I can hit Enter and run that line of code too. What's the difference? This line of code is 1 plus 1. This line of code is 1 plus 1. And we see that there's a space here. In R, between our operator, an operator is a plus or a minus, between the sign and the value, the number, we can add as many spaces as we want, and it doesn't affect running our code. Okay, so if I wanted to organize my data with spaces, I could use these spaces and it will run my code uninterrupted. See? So we have 1 plus 1, and here's our result 2, right? These spaces don't matter in R as long as they're between the values or the operators or the functions. So right now we have 2 values, 1 and 1, and we have 1 operator, this plus symbol. Let's go down and look at a little bit more complicated code right here. Again, to run my code in my script, I can highlight it and hit Enter. As you move up and down with the arrow, it will highlight that line of code. When that line of code is highlighted, I can hit Enter, Command Enter, or Control Enter on Windows and run that line of code. If I wanted to run a specific part of my code, I could do that as well. So if I wanted to outline just what is 10 plus 1, you can see that only this part of my code is highlighted. Now if I run my code by hitting Enter, it's only running that piece of code, 10 plus 1. Okay, so in R, when we're using our script, it's very easy to run parts of our code without having to run a whole line if we don't want to run that whole line. Okay, so for example, if I want to know what is 1 times 9, I can highlight that, hit Enter, and it shows me down here. It ran just that part that I highlighted and gives me the result down here. Again, this is the index telling me that is the first result from this line of code. Okay, so to run a line of code, we can use the up and down arrows. And when the line of code is selected that we want to run, we can hit Enter. On a Mac, it's Command Enter. On Windows, it's Control Enter. So I can just up and down and select that passively and run that full line of code. Or we can highlight specific parts of our code and run only that part of code if we want to, if we just highlight what we want to run specifically. Okay? All right, so let's move on to simple functions. Here's a function called square root. And what this does is anything we put in the parentheses, it's going to calculate the square root of that number. So this is called a function because it functions, it does something. In English, we have rules to the English language, right? We have a noun, something, and we have a verb, something that gets done. In this case, a function is like a verb in English. It does something to our noun or to our value. In this case, our function calculates the square root, and our noun, our value here is the number 9. Okay, so what is the square root of 9? I'm just going to hit Enter here, Enter, and it tells me it's 3. Now you can see the next code I have is the square root of -9. In other words, what times what equals -9? Well, the result is there is not a number, NaN, there is not a number that multiplied together equals -9. At least no real number equals -9 if we multiply it by itself. So we get the result NaN, NaN meaning not a number. Not a number produced means there's a warning. Are you sure that's what you wanted? R is giving us a warning message to just let us know that maybe that's not exactly what we expected would happen. We can create our own function. So in this case, my function is called function of x. And I'm going to call that fun. Okay, so what does this function of x do? It does what's in these squiggly brackets over here. We call those braces. Inside those braces, it will take x, whatever we input, and multiply by 10, and that will be the result. Let's run this line of code. Enter. We see down here, it ran our line of code, but there's no output. Why not? What did this line of code do? It made this function equal to this word here, fun. So every time I use the word fun with a bracket, it will run that code. It will run that function. What does my function do? It takes my input and multiplies by 10. Now let's run this. What is my input in this function? The function name is fun. The input is 1, so it's going to take 1 times 10. Enter, and we get the result 10. Let's try it with 90. What's going to happen with 90? It's going to use our fun function. It's going to take our input x and multiply by 10. Our input's 90, so we're going to have 90 times 10, which equals 900, right? All right, so let's try and run this with 2. Let's run this code down here. Here's my function, function 2. What's going to happen? We get an error. Why did we get an error here? Well, R is a case-sensitive language. What that means is a capital FUN, let's run that, is not the same as a lowercase FUN. The lowercase is saying it's a different function, so R is saying we could not find the function called fun in lowercase letters. Okay, so always remember, a capital letter is not the same as a lowercase letter in our programming language. Okay? All right, so let's look at how we could use R for statistics. Here's a quick example. I have a variable, height, and a bunch of numbers on my right, 151, 174, 138. What that means is the first person has a height of 151. The second person has a height of 174. The third person has a height of 138. C just means I have a lot of numbers. I'm concatenating a large string of numbers. We call this a vector. We'll talk about that a little bit later in the course. Okay, so here I have a vector of numbers, multiple values. Next, we have this operator. This is an arrow. It's showing that this value over here, a string of values, is being assigned to one variable. What does that mean? Let's run this code. I'm going to hit enter while this line of code is highlighted, and it just ran this code here. What does this mean? It means these values are being saved in the variable called height. So that means every time I write HEIGHT and hit enter, it'll show me the results were saved in that variable. So every time I want to use this variable, it remembers all those numbers. Let's do the same thing with weight. Here we have the first person is 63 kilograms, the next person is 81 kilograms. So run this code. And again, if I want to find the value of that variable, I can type the name of the variable and hit enter, or in my script, I can highlight the name of my variable and hit enter, and that will give me the same result. It runs the name weight as the input to my prompt, and I get an output of what the values are. In other words, this is an easy way to save a lot of numbers. All right, so let's plot it. We can use a function called boxplot to show us the maximum value is above 180, somewhere around 190 maybe. And then we can see the median. Here's the median around 150. The minimum is around 128, 127, something like that. Okay. This shows us the distribution in general. And if I wanted, I can run this code. It's the same. I'm using my box plot, and I'm making a box plot of the height, but now I'm changing an argument. The color is going to be blue. And now I get my box plot, but my box plot is blue. Now these codes are a little bit advanced. We're going to slow down. I just want to show you how running codes will look like. If I run a code that results in a plot, some kind of visualization, it will automatically pop up a new screen, and this is my visualization. This is base R. Let's go down a little bit. I want to plot the relationship between height and weight. This will be my X, this will be my Y. Let's see what happens if we run this code. A plot pops up. It's showing my height on the X-axis, the weight on the Y-axis, and then each individual. This person has the height around 128, maybe 129, and the weight around a little bit less than 50, let's say 48, 47, right? This person up here has a height of 162, 163, and their weight is around 71, 72, right? Okay, so here we've plotted each individual in our data set. And now, if I go over here, we can change some options. We call those arguments. One argument is the color. I can change the point character. Basically, is it a circle? Is it a square? Is it a colored in circle? CEX is the size of each point. Main means I'm adding a main title to my plot. So let's X out our basic plot and run this line of code here. Enter. Now we see that we have a much more complicated result. Each point is filled in. They're a little bit bigger, and we've added a title to the top and changed the color of the points. Let's click on our script. Let's go down here. We're going to make a linear model. This is a regression model. Again, we're going to talk about these codes in much more detail later, but let's just see how we can quickly make a regression model and actually plot the results. So this is showing the relationship between X and Y, and we're going to make that as our model. Down here, we see that it ran our model, and it saved this linear model to the variable model. And now I can write A, B line, draw a line from A to B on our plot using our model, the relationship between weight and height. So I'm going to look at that. And let's look at our plot. It drew this line across our plot. Now, our line is a little ugly. It's just a black line, very basic, not too interesting. So let's change the color of the line to green and change the line width to 3, make it 3 times thicker, and run our code. What we see is we get a thicker line. Now it's a different color, but it's a little bit more fun. Is it nice and easy to read? Not really. We're just exploring the different possibilities. Okay, and then we can check our model statistics using a function called summary. Model was our regression model, which is a relationship between the weight and the height. Let's see what that gives us. Run that line, and we see we get a bunch of statistics in our console. So I can scroll through those, Call is telling me this is the formula. It's the relationship between weight and height. Here it's giving us some complicated output about the residuals of our model, the error of our model. If we come down here, coefficients tells us the relationship between height and weight, gives us an intercept. It gives us the standard error. It gives us a t-value, a statistic on the t-distribution. And then it gives us a p-value. This is the probability that that t-statistic is greater than a certain number. Then we get some little stars. This tells us whether our result is significant or not significant. If we see stars, the more significant our result is. Down here, this tells us if we have 3 stars, the significance is less than the number 0.001. If we get 2 stars, it's between 0.001 and 0.1, and so on. We'll come back and talk about this later, but I just want to show you it's very easy. The code is very short to get a really complicated list of results. This is showing us all of the statistical relationship between our height and weight by using a regression model. And we'll discuss how to interpret this a little bit later in the course. Again, on top, this is our script, and on the bottom, this is our console. What is our script for? Our script is for running our code, writing our code, changing our code. If I want to organize it a little bit, I can add that up here. I can kind of change my code up here. Maybe if I wanted to change the color, I could change the color, run my code. On the bottom, our console is actually processing that script. It's processing the code line by line as we add it. And you can see I changed this line to red by changing my script and running that script. All right, so let's do the same thing. We'll do it much more quickly in RStudio, just so you can see some of the differences between R, base R, and RStudio. Okay, so when I open RStudio, it looks very similar, right? So let's try that same thing. Last time we said 1 plus 1, and hit enter, and it gives us the result. Looks the same. Okay, so this is the console. We see there's also a terminal, background jobs. We don't need to look at that yet. If we go up to this plus option, this means make something new. Okay, so if I wanted to make a new R script, I could click here. Here's a new R script up here. My console moved down to the bottom corner. So now let's write something in our script. Let's say 2 plus 2. And I'm going to hit enter again. In this case, I hit command enter, and it runs my code down in the console. And my script is up here. It's untitled and a star, meaning we haven't saved our changes yet. Red means we haven't saved the file. The star means we made some upgrades or some changes to our script and haven't saved that yet. Okay, if I come up here, there's a file that says open an existing file. I'm going to click on this, and next I'm going to find the file that I want to open. I want to open that test drive file, the same script that we opened in base R, we're going to now open in RStudio. So let's try that. Okay, so this is the file that I want to open. So I had to find which folder it's in, open that folder, and this is the file I want. It's called test drive of our programming.r. .r means I can open it either in base R or in RStudio. This is a script file. So let's open that. What we see is a new tab opens. So here's our original 2 plus 2 file, red because it hasn't been saved yet, star because we made changes. Here's my new file, and it's a little bit, it's a little bit hard to read. So if I go down here, you see that my cursor turns into 2 little arrows, right? One up and down. If I click that, I can move it down. I see more of my script and less of my console. So then I can scroll up and down. I can see a little bit more of my code up here. Okay. So now if I run this, I can run my code up here, 1 plus 1. Let's hit command enter. It runs my code down here, 1 plus 1. The result is 2. Here's my other code, 10 plus 1 times 9 minus 1. Let's run that code. We see the result shows up down here. And up here, my cursor skips to the next line of code where there's some information. Here's square root here's square root of 9, run that code. Square root of 9 minus 9, run that code. And you'll see my cursor jumps to the next line of code. We can also easily see the line number on the left. Okay. All right. If I scroll over, you see that there's a little bit of a shadow here. That's just telling you you're not all the way to the left. Okay, so I could run through all these codes. Let's run this function. Okay, I ran my function. I can run this function here. Cool, right? All right, so let's go all the way down and look at our regression example. And I don't need to run lines one by one. I can highlight all of these different lines and run them together. So I'm going to run my height, my weight, and my box plot. You'll see that up here there's a hashtag enter data. Anytime there's a hashtag, it means that R is going to ignore anything after the hashtag. This is how we write notes using programming. All right, let's run this code here, and it should save these numbers as height, save these numbers as weight, and then make a box plot of my height variable. And you see, when I plotted that, it created a plot on my right side of the screen. Again, you can see that if I move my cursor, I can move where my box plot, where my plot is, and where my script and console are. Okay, so if I move this over, my box plot becomes a bit bigger, but my script and my console become smaller. Okay, if I bring this down a bit, there's actually a lot of information up here as well. So if I bring this way down, I can see all of the variables and functions that I've made. I made a variable called height, and it's the numbers 151, 174, 133. Okay. If I come down here to weight, it also gives me those values too. So here I've created two variables. One is called height, one is called weight. And I've created one function. That function is called fun, right? And if I hover over this, it tells me I've got a function. Here's my function. If I click it, it'll show me what that function is. My function is my function of x, whatever I input is x. Take that input and multiply it by 10. Okay, here's my old script. So you can keep track of many different scripts, many different functions up in this top left corner. In the bottom left, we have our console. In the bottom right, we have our figure. And in the top right, we have our variables and functions, our environment that we're creating. And as we go, sometimes we might want to see our, plot, and sometimes we might want to look up here at our environment. If I zoom in, everything gets bigger. If I zoom out, everything gets smaller, but I can see more of it. Okay, so if you're having a little bit of a difficulty seeing everything, you could zoom in or zoom out. You'll be able to see more or less. And you can also adjust the size of each area. So if I want your console bigger, then your script is smaller. If you want your script and console a little bigger, then your environment and your plot gets smaller, right? So everything's a trade-off in RStudio. Let's jump down here and make a plot. I like this hot pink dots. And then we can make our model a green line. Cool. And if I check my summary, now I can see that my summary is in this bottom left corner, so I can read the output of my model in the console. Let's make our console a little bigger. So if we're analyzing our data, we can check our console, we can make our plot bigger, we can see our plot right next to our model results, right? Okay, so that's RStudio. So this is why many people prefer RStudio, because you can adjust the size, everything's in the same spot. Your script is always the top left, your console is the bottom left, The plot window is the bottom right, so it makes it easy to organize your results. However, there's a lot of extra information that you might not need to know all the time. So for that reason, I actually prefer to use base R. So for this course, I'm going to be using base R. However, you can use whichever one you like. If you prefer RStudio or if you prefer base R, feel free to use either one. The results will be the same. Okay, so we just looked at our test drive of R programming. I don't want you to understand everything in that test drive of R programming. It's a little bit complicated, but it gives you a better idea of what is the difference between our console and our script, and what is the difference between our environment and any plot that we might have. Okay? So next, let's explore more deeply how to program in R. Like, what is each line of code doing exactly? Let's get into the details of R programming. All right, so I've opened our second code file for today, which is the fundamentals of R programming. And what this code is meant to teach you is the basics of using R. All right, so you'll see that each section has a lot of hashtags. This means that it's just a note. The note means it's for whoever's using the script, whoever's writing your R script. Okay? This just lets us read the script much easier, but it won't run in the console. On top, we have our script. I can make it a little bigger. On the bottom, we have our console. The console is where the results are, and the code is processed. The top is where we write our script that we want to run. Okay, so I can scroll through my script. This one's a little bit long, right? We'll go through all of this right now. And on the bottom, we have our console. Right now, it's a new R session. So it's showing me the R version at the beginning of every R session. I can scroll down here. We see that there's no results that have run yet. Okay, so you can make it bigger or smaller as you wish. And let's make this a little bit bigger up here. Okay, so my first code up here, I have hashtag 1+11. Now, as I said, we can scroll up and down using the keypad. So if I scroll up here and I run this code, what's going to happen? I'm going to run it, enter, and what happens is down in our console, our prompt says hashtag 1+11. And then there's no result. Why? Because a hashtag means anything afterwards, anything to the right of it, is going to be ignored by R. So because 1+11 is after it, it's just ignoring it. Now what would happen? How could I run this code? I could just highlight 1+11 and run this part of the code. Let's hit run. What we see is it says 1+11 and gives us the result 12. Why? Because I didn't include the hashtag in my line of code that I'm running, so it just runs my code, 1+11. Quite easy. Okay, so what is an operator? An operator is an operation that we're doing on some values. In other words, in this case, we have 1+11. What is our operator? It is plus. We're adding them together. Okay, and what are the values? Well, we have a 1 and we have an 11. All right, so let's look at our first example here. We have 1 + 2 × 4. We have 1, 2 operators, right? Plus, and this star, this asterisk is multiply. So we have 1 + 2 × 4. Sometimes you see this on TikTok or Instagram Reels or YouTube Shorts where someone is asking a question like this, some simple math problem. Well, what do you think is the result? 1 + 2 × 4, we run it, we get 9. Why? Well, there's an order of operations. There's an order of operations in mathematics, and there's an order of operations in programming. That order of operations is as follows. So if we see up here, I've organized the first, second, third, the order of those operators, the precedence. So first, we have a hashtag. If we have a hashtag, it'll run that first. Anything after it, it ignores. Next, we have brackets. In other words, if there's brackets, it's going to solve whatever is in the braces, the squiggly lines, and then it's going to do the other operators. If we have parentheses, it also does that before other operators. If we have a $, we'll talk about these a little bit later in the course. Okay, so $sign is used when we've got some data set and we might want one column of our data set, or one variable. These square brackets are used for indexing. We're going to get to that a little bit later. These are used for exponentials. We'll possibly get to that later in the course. We have a ... meaning from one number to another number. We'll get to that a little bit later as well. Then we've got matrix multiplication. Again, we'll get to these later. Next, we've got asterisk and slash. What this means is multiply and divide. These are the same level, meaning it's going to do these first before anything after it. Okay, so it'll do these from left to right. So do we have any of these in our code? Yes, we have this multiply sign, this multiplication operator. So what happens first? 2 multiply 4 happens before this plus sign. So 2 times 4 is 8. So it's the same as saying 1 plus 8. Why? Because this operator happens first, which multiplies 2 times 4. Then the plus sign is used. So why is that used next? Because it's lower on our order of operations. So the plus and minus are used second, okay? All right, so then we would have 1 plus 8. What is that? That's 9. That would be the same as 9. Okay, so if I run this code, 1 plus 2 times 4, we get 9. If I run this code, 1 plus 8, we get 9. If I run this code, we get 9, right? They're all doing the same thing. This first one is just doing them one by one, 2 times 4, then 1 plus 2 times 4. All right, let's look at our next code here. We have quite a few different operations here, right? Now, you might have figured out what the answer is already, but how do we run this code? Well, first, let's clean our console down here. How do we clean it? We hit that option command L, and that'll clean our console. So now we've got a nice clean console. Okay, and then let's run this code. What are we going to get? Well, it's going to do what first? It's going to do these braces first. So everything inside our braces is going to happen first. All right, so what's happening in these braces? Well, we have 2 to the power of 3 divided by 1 plus 1 in parentheses. Well, what happens next? First we have our braces, then we have a parenthesis. So what happens next? We would get our 1 plus 1. What does that mean? That is 2. Let's run it 2, right? So it's the same as saying this part is 2. It's the same as saying this part is 2. Okay, so next, what happens after that? Do we see any other operators? Yes, we have to the power of right here. That means 2 to the power of 3. What does that mean? That gives us 8. Why? That's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So we get 8. So this part here is 8. Okay. Then we have divided by. What is 8 divided by 2? That's our next one. 8 divided by 2 is 4, right? 4. So in the brackets here, we have just 4. All of this gets calculated one by one in that order, and we get 4. So what happens next? We get 4 times 0. What is 4 times 0? That would be 4 times 0 is obviously, 0. So if we run this code up here, we actually get 0 because it breaks down one by one. This is 2, this is 8. 8 divided by 2 in the brackets would be 4, and then 4 times 0 would be 0. Okay, so the purpose of this little code up here is just to show you this order of operations. All right, next, continuation prompt. So if we have 2 times 4, what'll happen? Let's clean our script and run our code. I'm going to run this code. And on this line, we have 2 times. So in our prompt, in our console, we have 2 times. We see our prompt turned from an arrow to a plus. That means it's not finished with the code. Why? Because I said 2 times, and R is waiting for 2 times what? So I'm just going to run our next line of code here, 2 times 4, and then it gives us our result. Okay, this is continuation. It's not finished with the line, so it's waiting for you to finish the line. Okay, next, let's talk about assignment operators. The assignment operator is equal. That means everything on the right side of the equal sign is assigned to the variable on the left. What is a variable? A variable is just a word that saves a value. The value could be a numeric value. The value could be a lot of numbers, like we saw before with our height and our weight variable. Our value could be a string, a text data could be saved. So that variable is a word that can hold the value of whatever we have on the right side of it. What does that mean? That means let's run our code. And on the right side, we have 2 times 4, which is 8, equals Ian. So if I write Ian, what value got saved here? We hit enter, 8. In other words, the value stored in the variable Ian is 8. All right, here's another one, ASDF. Our variable name can be almost anything with a few limitations. So in this case, our variable name is ASDF, and our operator is an arrow. This is an arrow saying, save the value on the right into the variable on the left. That's what this arrow is doing. It's putting the value into the variable. So let's run this code here. I'm going to clean my console and then run my code. All right, so now what's going to happen if I run this code? I'm just going to run ASDF. It's going to give me the value stored in ASDF, which is 0.75. Okay, so it calculated the result first and then saved the value over here. Why? Well, if you go way up here, this is the order of operations. At the very end, we have our assignment operators. In other words, it's going to do all of our calculations first and then assign the value to a variable if that's on the same line. Okay, so what happens first here? We have our multiplication operator, then our assignment. What happens here? We have our division operator and then our assignment to the variable. All right, so if we wanted the contents of the object, so in other words, here's our object Ian, our variable Ian. If I run this, Ian is my name, that's why I'm using it. 8 is the value that was saved inside it. ASDF was 0.75. What happens if I multiply Ian times ASDF? Well, what is the value of Ian? 8. What is the value of ASDF? 0.75. We're going to get 6 because 8 times 0.75 is 6. Okay, so in other words, we can use our variables here. Let me make it a little smaller. It's a little confusing because my note is going to the next line. Here's my note. So my variable, Ian, ASDF, these can be operated on, and the values that is being stored are being computed. In other words, Ian is 8, ASDF is 0.75, so we can multiply those like we could just using those numbers. 8 times 0.75, enter, the same result. All right. We can use last value. This is a special command in R, and it'll just give you the last value that was the output of whatever the previous code was. Okay, so in case you forgot what it was, or in case you want to use that value to make a new calculation, we can use this code called .last.value. We can also assign that value to a new variable. So let's do that with x. So now what is the value of x? It is the value of last value. What is the last value? 6. All right. If I have a variable or an object that we don't want anymore, I can use the function rm for remove. What does that do? That will delete my object. In other words, if I want to know what is x, it's saying there is no x. Why? Because this function rm deleted it. Okay. We can also use remove. This will do the same thing. And now ASDF has also been deleted. Now what happens if I run this Ian? Has Ian been deleted? No, it still has the value 8. It didn't delete because we never deleted it. So there's something important to remember in programming languages, specifically using R, which is there's no back button. There's no undo. If you're using Microsoft Word, you can just hit back or undo. In Python, you can't undo anything. Why? It runs line by line in your console. Whatever you've run in your console has been saved as forever for that session. In other words, because we gave Ian a value way up here, right? Ian was 2 times 4. Way down here, Ian is still 2 times 4, 8. We gave ASDF a value, way up here, 3 divided by 4, which is 0.75. And way down here, we removed it, and now it doesn't exist anymore. Okay, so be very careful when you're using R. It's a good idea to save your code very often, so if you make a mistake, you can go back and rerun your code. That's the benefit of having a script, is we can change our code very quickly as we wish. All right, so what is a legal name to use? In other words, what is a valid variable name? Ian is valid, right? Let me just clear that. Ian is a valid name. Here's a capital I, Ian. What's going to happen? I get an error. Why? Because a capital is not the same as a lowercase. Let's go down. Let's say we give Ian the value 0. Now what is Ian? 0. Here's Ian with a capital I. Let's give it the value 1. Now what is Ian? With a capital I is 1. We can also use a dot, the same as any other character. Okay. We can also use a number at the end of our variable name, like this, no problem. The only issue is if the number is the first character, we get an error. Unexpected symbol means the first character of your variable cannot be a number. Okay, so if I check, I'm going to get an error. Okay, if I want to know what are all the objects, what are all the variables that we've made, let's clear our console. If I want to check what objects we have, let's run this, and it tells me all of the variables that are saved in my R session. If I exit R, I'm going to start from the beginning every time. So these objects are created through my code, and they'll save there until I exit R. I can also use the question mark. What the question mark does is it tells me the usage of a specific function. So in this case, I'm using the function objects. So it's telling me this is a base function. It comes with R, and it's called objects. And this is how you use it. Gives you a little bit of a explanation of what are the arguments to this function. We'll come back to this a little bit later, but what this means is we can use a question mark to figure out how is a specific function used. We can also use the function help to do the same thing. It shows us the function is called objects. Here's all the arguments. It's the same thing. Okay, so the question mark or the help function will give you a detailed explanation of what that function does. Let's talk about data types. There are a few basic data types. One data type is a numeric data type. Class is a function that tells you what type of data you have. This data is a string or a character data type. A string means that it's text data. A character means it's text. In other words, we can't add and subtract text, but we can add and subtract a number, numeric. We've got another very basic data type, which is called logical. In different programming languages, we might call this Boolean. It's true or false. You see that in R, we use true as all capitals, or false as all capitals. And as I write false, you'll see that, oops, F-A-L-S, it's all in black, but once I finish the word false, it knows that it's a logical data type and turns orange. You'll see that also F is a logical data type because F is short for false. So you might guess what is the shortening for true? You could just use T. That's also true is T, false is F. It's just a short version of it. Okay? If I use true in lowercase letters, it is not orange because it is not a logical data type. It's looking for a variable called true. It's looking for an object called true, but there is none. So remember, if you're using logical data, true or false, it has to be all capitals in R. All right, so let's use a numeric data, 105. Here we go. And the value of this value is 105. The class of my value is numeric. Okay. If I wanted, I could change that. Let's make a new variable, a new object called string. And we'll call this hello world. The string, hello world. Okay, so what does that data look like? It looks like hello world in quotation marks. Quotation marks signify that we're dealing with text data. In R, we call text data as character data. You might also call it a string, but when we check the class, it's called a character. All right, let's look at logical. Logical, we can see we have a value 2 and 4, and now we have a new operator. This is a logical operator. What does it mean? It says 2 is less than 4. You might have remembered this from elementary school. The alligator is always eating the bigger number. We said that in the US. I'm not sure if you have the same thing, if you learned the same thing. So this one is eating the bigger number, right? It's eating toward the 4. It means 2 is less than 4. Is this true? Yes, that's true, right? So the output of this statement, the output of this code is true. How about this one? 2 is greater than 4. This is not true. 2 is not greater than 4, so we get the output false. So if I say class, what's going to happen? Well, first, it's going to calculate the inside to false, and then it's going to do the class of that output, which is a logical class. Class is the type of data. All right, we have complex numbers as well. We don't use these for statistics very often, but you can also have a complex data class. This is not very useful for this course, but it might be useful if you're a mathematician or need it for some other purpose. Okay, so in this case, we can create a more complicated class by using a function. This function is called as.date. Remember that the D in date is a capital D. What this will do is it will change this into a date data type. Okay, here's white day, 2026-03-14. So what would happen if I wrote the code here, class, white day, and run this code? We see that it is a date class. All right. Next, we'll use Valentine's Day. And let's do this one as 2026 as well. All right, so here let's run this. Valentine's Day is 2026-02 February 14th. So I can also do a calculation. What is the operator in this calculation? Minus is an operator. So here, using a date class, what is the difference between white day, 2026-03-14, and Valentine's Day 2026-02-14? The time difference is 28 days. Now you might have noticed that there's an argument over here that says %y dash %m dash %d. What this is saying is this is the format of the date that we input. The first value is a year in the format of 4 digits. So in order to indicate that, we use %y. Big Y means 4-digit date. Then we have a dash, like we have over here, dash. And then we have a %m, meaning the month here. Then we have a dash, and then we have a dash over here, indicating that this is the same format. Okay, you can use almost any format as long as you specify your format. But by default, we use the format the year in 4 digits, dash the month in 2 digits, dash the day in 2 digits. Okay? All right. So if we had a slightly different format, let's say we had let's say that we had the month, the day, and the year, which is American format, we could run this, and it will translate that into the date 2024-03-14. It will always show you the date in the year, month, day format, but we can input the date as any format that we want. So for example, if we input the date as the word March 14th, comma 2024, we can indicate that as %b, meaning the date as a month name, space, there's a space here, there's a space here, the day, comma, then we have a comma. So we can indicate any format that we want in this way, and it will transform that into the standard year, month, day. All right, factors. Factors means you have groups. In this case, we have groups A, B, C, D, F. We call that a factor type. In this case, we have C, and the possible values are A, B, C, D, or F. These are the different grades you might get for a class, right? So if I'm using this factor type class, it means that I have specific possible categories, A, B, C, D, or F, and then I have the data that I have, C. In this case, this is telling me I have a C, but I could have gotten an A, a B, a C, a D, or an F. Okay, let's look at an example. Let's say you have a class of students and one student is American, but you could have American, Korean, Chinese, French, or other students. This just happened to be who was in my class in a previous semester. If I check my nationality, it tells me my data is American, but it could be any of these groups, American, Korean, Chinese, French, or other. In that class, there were only these 4 different nationalities. Okay. All right, so if I say levels, it's telling me all of the possible groups that there could be. If I say table, it shows me how many values I have in each group. I have American as one result, but I have none for all those others. Why? because I wrote American here, and I said the levels are these possibilities. All right, so we're getting a little bit more complicated here. Next, let's talk about strings and vectors. So, strings. A string is made up of multiple characters. So, here is our first string, and I'm going to assign the value. This is our string value. We're going to assign this value to our object or our variable. Okay, so let's run this line of code, enter, and let's see what that looks like. It looks like this. Again, Ian is me. All right, so a string is indicated by quotation marks. So here we have a quotation mark in the beginning of our string and a quotation mark at the end of our string. When we start typing our own code, our own script here, we start with the quotation mark, meaning that we're writing a string or we're writing a character class type. And to indicate that we've ended it, we end with another quotation mark of the same type. Okay. You can see that the string also turns red in our script to tell us that this is not just any value or object, this is specifically a string or a character data type. All right, so we can use some functions like nchar, which means the number of characters. And if I input our string, this is our object. What is the value that this object holds? It holds the string value or the character value. So let's run this code here. We get 16. Why? Because there's 16 characters. So let's count. 1, 2, 3, 4. The space also counts as a character. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The question mark or any exclamation or punctuation marks also counts as a character. So spaces, letters, even numbers that might be inside our text would also be counted as a character. All right, so what is the length of our string? 1. All right, so what's the difference between this nchar function and the length function? The length tells us how many values we have. The nchar or the nchar tells us the number of characters. And in our string, that's just telling us how many letters, including spaces, including numbers that we might have. Next, let's look at this vector. We have a vector, meaning multiple values being held in one object. What does that mean? Well, let's look at our code here. How many values do we have? Values can be a lot of different data types. In this case, we have multiple values that are character data type. So what are they? We have Ian. How do I know this is a value? Because it starts with quotation marks and ends with quotation marks, making it a character value. Okay, then we have a comma. This C, or concatenate function, how do I know it's a function? Because we have parentheses. So we have C and then parentheses after it, meaning it's a function. Anytime we see a word with parentheses after, it almost always means that we're using a function. In this case, we're using the C, or concatenate function, which says we have multiple values inside our function, and we're going to hold those into one position. We'll come back to that a little bit later. All right, so here we go. We have 1, 2, 3, 4, 5 character strings in our vector. So what does our vector look like? When I say my vector, 1, again, this is the index next to the first value. Okay, so here's the first value, Ian, is the best ? question mark. We have 5 different values here. So if I write n character vector, what's going to happen? It tells me the number of characters in every value of our vector. Right? So the first value is Ian, which has 3 characters. The next value is, which has 2 characters. The next is the, with 3 characters, 4 with best, and 1 with the question mark. Okay, so a function is being applied to our vector. What is a vector? It's multiple values together. All right, so when we apply a function, or when we apply most functions, it can act on each value of our vector one by one and give us the result. So 3, 2, 3, 4, 1. In other words, it's acting upon all the values of that vector. All right, next, length. What is the length of this? Again, the number of characters tells us how many characters are in a string or in a character type data class. Length tells us what? It tells us how many values are in our object or our data. In this case, what is our object? It's called vector. So how many values are in our vector? 5. Ian is the best question mark, right? 5 values. Okay, so now we can index. In other words, vector has 5 values in it, but what if we just want one of those values? Let's say that I just want the first value of our vector. So if we index those values, 1 refers to the first value of our vector. So let's see if that is what we get. Vector, meaning this is the object holding our data. 1, meaning this is the first value in that line of data. Okay, so in R, the indexing, meaning which comes first, which comes second, which comes third, starts with 1, which is pretty intuitive, especially if you're not used to programming. So what are these square brackets? These square brackets mean from that data set, we want to select data out of it. In other words, what is our data? Our data is vector. What is vector? It's 1, 2, 3, 4, 5 character type values. Ian is the best question mark. So out of our data, if we use square brackets, it means we're getting something out of that data. So what are we getting? We're getting the first value. So that's why it gives us the first value. So what would happen if I wrote 4? Well, that means it's going to give me the 1, 2, 3, 4th value in our vector, which is 1, Ian, 2 is 3, the 4, best. So what is vector 4 going to give us? That would give us best, because that is the 4th value in that vector, in that line of data. Next, let's make a new vector. Let's call this vector x. And x is going to be the values 0, 3, 5, and 10. Okay, so let's assign those values to x. What's going on in this code here? Well, we have the C function. What does the C function do? It concatenates. You can think of it as combining a lot of different values together. And each value is separated by a comma. So how many values do we have? We have 4 different values here. Then we have the assignment operator. What does this do? It says any value on the right of it is going into the object or the variable on the left of it. In other words, you can think of it like an arrow pointing this value into this variable or this object. So if we say x, what do we get? We get 0, 3, 5, and 10. If I say x1, what am I getting? I'm getting the first value of that vector, which is 0. In other words, the sequence is important. It saves the sequence information. What is the first, the second, the third, the 4th value? Because when we index, when we try to get a specific value out, we can use the index number associated with that. All right, so what if we tried to do math? What are these functions here? We have multiply and we have add. So I'm saying x times 100 plus 1. What's that going to give us? That's clear. That gives us 1, 301, 501, 1001. Why? Because it applied this mathematical formula to each value in my vector one by one. So what was the first value in my vector? The first one was 0. What's 0 times 100? 0. 0 plus 1? 1. So that's why we get 1 here. Our next value is 3. So 3 times 100, 300. 300 plus 1, 301. That's why we get 301. Okay, so we applied the same mathematical operation to every value in our vector. Okay, and that's how we get this result. All right, so what if our vector was a little bit different? NA meant it's a missing value. So what if I made a new vector with a missing value, 0, 3, missing, and 10? Now let's see what happens if we hit Y. We get 0, 3, NA, meaning missing value, and 10. All right, so let's go back and look at X. We have X and Y. Let's look at X. X is 0, 3, 5, 10. All right, so I'm going to use length of X. How many values do we have? We have 1. This is the first value. 2, 3, and 4. So we have 4 values. So the length of our vector X is 4. Tells us how many values. Next, we have the mean function. What is a mean? This is the average. So what is the average of X? Well, you can add them all together, divide by the number of values, and you get the mean. This is the average. The median is the middle value when sorted. Well, what's the middle value here? We have 0, 3, 5, and 10. Actually, we don't have one middle value, we have 2. Both of these values are in the middle when we sort our values from the lowest to highest. So what is it? It's the average between these two middle numbers. All right, so let's see what we get. What's the average of 3 and 5? It's 4. So the median is 4. The standard deviation, this tells us how much deviation, how much dispersion the data has. All right, 4.203. We'll talk about standard deviation in a lot more detail in a following lecture. Next, we have sum. This just adds everything up together. We get 18. That's 0 plus 3 plus 5 plus 10, right? Finally, summary is a really useful function in R because it gives us a 5-number summary. The minimum value, which is 0, the median value, which we calculated as 4, the mean, which was the average, and the maximum. We get 2 more values here too. One is the first quartile. This is the median between the minimum value and the median. In other words, it tells us 25% of the values are below this number and 75% are above this number. The third quartile is the median between the median and the maximum. We'll talk about these a little bit later in the course. Okay, so what if I wanted to, let's go back a bit. Let's say I wanted to do the same thing, but this time, instead of X, I want to use Y. So let's clean our R console and rerun the same code, but instead of X, I'm going to use Y. And what was the difference between X and Y? Well, the difference is that Y is missing a value. So here's Y, 0, 3, missing, and 10. So what is the length of Y? How many values do I have here? Do I have 4 values or do I have 3? The length includes missing values. So here it tells us we have 4 values. We have a 0 value, a 3 value, a missing value, and 10. That'll become important a little bit later. Now this is where it gets a little bit tricky if you're new to programming. So let's calculate the average. What is the average? Well, it's the sum of all of these values divided by the length, or the number of values. Okay, so when I try to get the mean, I get NA. Why? Because we have one missing value here. There's no way to know what the actual mean is. So by default, R will tell you that it's missing because we don't know. So if we want to do something different than the default function intends, we can do something called changing the arguments. Okay, this sounds complicated. What does it mean? Let's go down here. Do you remember this question mark? The question mark means a help menu. So if I run this code here, it's going to give me a help menu. Let's check. This help menu, let's make it a little bit bigger, gives us some information. So let's think about how to read the help menu. Mean is the name of the function. Base is where that function is. Base means when you download R, base are the basic functions of R. It means it's included with your download of R. Okay? All right, so what is it? Description tells us what this function does. It gives us the average or the arithmetic mean. Okay, then it tells us how we can use it. To use it, we use the function mean in parentheses x. X is our values. If I come down here, under arguments, it tells me what x means. It's an R object. Currently, there are different methods, blah, 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 right? This tells me that we can use numbers, logical, date, date time, or time interval objects, okay? What's missing there? Well, we can't use character objects. You can't calculate a mean from a character, right? So this is giving you some information of the limitations of how you can use this function. Then, if we look down a bit, it gives us some extra arguments that we can use. One is called trim. We can do a trimmed mean. This means that it's cutting off some percentage of one side or the other vector. We can also do something called na.rm. This is the important part that's very useful, especially for this course, especially for statistics. So na.rm means a logical evaluating to true or false, indicating whether NA values should be stripped before the computation proceeds. What does that mean? It means na.rm means should we remove the missing values or not? If you say yes or true, then it will remove the missing values and calculate the average. If you say false, we'll get the result that we just did. It will tell us NA, meaning it's missing. Sometimes there's some references that tell you how they wrote the calculation for whatever they're doing. Then they also give you some similar functions, and usually there's examples at the bottom that show you how you can use that function. Let's try to use that na.rm. So how do I use it? Here's my mean function. Y is my data. And to change the behavior of the function, I add a comma, meaning I'm adding something new, and the argument called na.rm equals, what do we want? We want it to be true. So now let's try and run our mean again. And now it calculates the mean after removing those missing values. All right, so this is a very useful process. If I try to use median, I get the same result. If I add that NARM equals true, it calculates my median after removing the missing value. Same with our standard deviation. We'd have to add that extra NARM argument and that will calculate the standard deviation if we have missing values in our data. What about sum? We also need it for sum as well. Okay. How about summary? Let's try and run summary. What we see is it ran the calculation. We don't need to add this NARM true. It ran the calculation. It tells us our median, our mean, our maximum, our minimum, and it adds this extra column, how many missing values there are. Okay? All right, so in other words, not every function has this argument or needs this argument. In order to calculate a lot of basic statistics, we often need to add this na.rm argument if we have missing data. There's also a function to check if we have missing data or not. This is.na. This is the function name. And what it's going to do is it's going to apply is.na to every value of my vector. Okay, what was x? X was 0, 3, 5, 10. So when I use is.na, the first value I get is false because the first value is not missing. The second is false because it's not missing. Third is false, and the last one is false because these values are not missing values. If we use it with y, we get false, false, true, false. Why? Because the value of the vector y is 0, 3, missing 10. So we get false, false, true, because the third value is missing. So is it NA? Is it missing? True, it is missing. There's something very useful about our logical data type, that Boolean data type that gives you true or false. Okay, that's called logical in R. So what does sum do? Sum adds up all the values. Okay, so what is it going to add up here? In this case, I have a function inside a function. Okay, what does that mean? So what does is.na do? It gives us a result, false, 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 if there's nothing missing in our x. What's going to happen if we add this sum function? It's going to add them. Well, how do you add false? False is equal to 0 in R. True is equal to 1 in R. So if I sum all of the values here, we have all falses. What is that? 0, 0, 0, 0. What happens if we add 0, 0, 0, 0? We get 0. Now what about y? Let's clear. Y looks like this. If I run this code, I'm going to get what? 1. Why? Because is.nay, enter, false, false, true, false, is equal to 0, 0, 1, 0. So if I add 0, 0, 1, 0, I would get 1. So it's adding up all of the total number of true results. This also would tell us how many missing values we have in our vector. Now let's talk about one more thing, which is recurrent calculations. So what is x? X was 0, 3, 5, 10. What happens if I run this code here? Let's run this code and see what happens. Okay, something happened, but it's not showing us a result. So let's see what the result is. All right, so by running this code, it's telling us what x is, 0, 3, 5, 10. Our next line, we say x equals x plus 1. Now, how does this make any sense in programming language? We need to remember the order of operations, or the precedence of operators. So let me go up for a minute. In the very beginning of this code, we had this explanation of which comes first. So in our code, we have an arrow and a plus. We have two operators. Which one comes first? In other words, which one is farther to the left? Well, we see the plus sign here, where is our arrow? It's all the way at the end. Again, the assignment operator is always last. Well, what does that mean? That means when we look at our code here, this line of code, what's it doing first? Well, it's going to do the plus operator first, so it's going to put these together, x plus 1. What is x? 0, 3, 5, 10. What if I add 1 to x? Well, it acts like a scalar. In other words, it's going to add 1 to every value of my vector. All right, so now I've got x plus 1. I add 1 to every value and assign that to x. So in other words, it's updating the value of x. So now x is 1, 4, 6, 11. Now what would happen if I ran this code many times? Let's try it. I'm going to run the code every time I say a number. 1, 2, 3, 4, 5. What is the value of x? 6, 9, 11, 16. Why? Because we took x and added 1 every time. So the first time we add x plus 1, we have 1, 4, 6, 11. We're adding 1 to every single value. So 1 becomes 2, then 3, then 4, then 5, then 6. Now it's 6, 9, 11, 16. Does that make sense? So this is a recurrent calculation. We're updating the value of that object, of that variable. All right, recycle rule. So let's say I have two vectors. Here we have vector A and vector B. So let's just take a quick look. A is -1 and 5. B is 1, 2, 3. All right, so if I add A plus B, what's going to happen? A is a length of 2. B is a length of 3. So how can I add them? Let's see. I get a warning message that tells me the longer object length is not a multiplier of a shorter object length. And then it gives me an answer. A is -1 and 5, B is 1, 2, 3. So A plus B is calculating for each value, but because B has more values, we do what's called recycling the shorter length, the shorter vector. So let's think about it. What happened in our result? We add A plus B. So what is the first value of A? It's -1. What is the first value of B? It's 1. What happens if we add -1 and 1? We get 0, right? The second value of A and B is 5 and 2. So if we add 5 plus 2, we get 7. Now we have a problem because we have 3, but we have no value in A. That's the third value of A, because A only has 2 values. So what happens? A repeats the first value in order to fill in the shorter length of A. So in other words, we get 3 plus -1. Why? Because A is only 2 long, 1 and 2. If we're adding together a longer vector, which has 3 values, what do? We just repeat, we recycle from the beginning of A. So it becomes -1 plus 3, which is 2. All right, what about multiplying? Does it work the same way? When we multiply, it's working the same way. Again, we get that same warning message. R is trying to tell us, are you sure you're doing what you think you're doing? And then we get the result from A times B. It does it item-wise, one by one. In other words, the first value of A is -1. The first value of B is 1. -1 times 1 equals -1. Next, the second value is 2. The second value of A is 5. The second value of B is 2. So 5 times 2 is 10. That's why we get 10. Finally, there is no third value of A, so we go back to the beginning. -1 times 3 equals -3. Why does it stop there? Because the longer vector, B, only has 3 values, so we only recycle A, the shorter vector, for as many values as B, as many as the longer vector. Let's talk about vectors in more detail. Vectors are really important for statistics because a vector can represent a sample, A vector can represent a column of values. So if you have a data set, a vector could be one characteristic of your data. Let's look at how to make vectors. One way to make a vector is to use this colon. The colon means from the left number to the right number. So here we have from 1 to 10. That gives us all the numbers from 1 to 10. So here we get 1 to 10. Cool. Okay. If we have from left to right, and the left is 10, and the right is -1, it'll be all the integers between 10 and -1. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, because on the right we have until -1. All right. What if we put a really big number here? Let's try to put a really big number. Let's say 1,000. This is going to give us all the numbers from 1 to 1,000. It doesn't take any time, but what it shows us is this is the first index. This index is telling me that the number here is the first value. But if I have so many values that it goes onto multiple lines, then, for example, here I have 14. That's telling me that the first value on my second line is the 14th value. This, in square brackets, is the index for the first value of my next line, the third line here. Does that make sense? So what this is showing is at the beginning of each line, it gives you the index number, which value it is, out of the total values. So you could kind of scroll through there. Next, sequence, 1, 10. This is going to give you the same result as before, 1 to 10. Sequence means give me all the integers from the first position to the last position. We can augment it. We can change how this function works by adding the argument called by. If I say by equals 0.5, it means from 1 to 10 by 0.5. Let's run that. All right, so it's giving me all the values from 1 to 10 by the step 0.5. So that's why we get 1, 1.5, 2, blah, 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 blah. That's an easy way to make a very large number of values, or one long vector, by giving a starting and an end point and saying, what is the step, by what step? The repeat function works like this. It's taking the value here and repeating it this many times. Okay, so in this case, if I said 1 and 5, what this function is doing is saying it's going to repeat 1 5 times. So that's why we get 1, 1, 1, 1, 1. Next, repeat 1, 2, 3 2 times. All right, so what's going on here? Let's see, let's run this code. 1, 2, 3, 1, 2, 3. Okay. So what's going on? Our function works like this. The first position is what we're going to repeat. The second position is how many times to repeat it. So in this example, this is the first position. How do I know? Because the comma is after it. So before the comma is the first position. So what is this? Remember, I can highlight part of my code and run it. So let's just run this piece here, C13. I get 1, 2, 3. What do these do? What does 1.3 do? It gives us all the numbers from 1 to 3. What does C do? It concatenates the result to be in one position, to be one thing. All right? So here, we're saying repeat this 1, 2, 3. How many times? 2 times. Let's run that. That's why we get 1, 2, 3, 1, 2, 3. We're making our vector longer by repeating it. Finally, we could say a word. In this case, what are we repeating? We're repeating the value high 3 times. There we get high, high, high. Next, sampling. Sampling means to randomly select n values from the input in the x position. All right, what does that mean? Well, what are the values we have? This is our first position, or our x position. And if I hit enter, you can see 1.6 means the numbers from 1 to 6. 2 means how many values to sample. Let's run this code a few times. Let's run it. Let's run it again. Let's run it again. So every time we run it, we get a slightly different answer. And what it's doing, so sometimes it's repeating, but what it's doing is it's choosing two values randomly between 1 and 6. First time we get 6 and 4, 1 and 3, 1 and 3, 1 and 2, 6 and 3. It's random. Is there any pattern that you notice? The same number is never being selected twice. So in other words, it's selecting without replacement. Think of it like you have a bag, you reach in the bag and you pick out a marble. That marble says a 3. Then you put that down, you reach in the bag. Now the 3 has already been taken out. So the second number you pick is going to be a random number, but it cannot be 3. If you want it to be selected again, we can use an argument called replace. Replace means after you select a number, you can replace it, you can select the same number again. Okay, so let's try our second code here, sample 1 to 6, 2. This means choose a number from 1 to 6 2 times, and replace equals true means you can select the same value multiple times. So we get 3 and 2, 3 and 6, 6 and 2. Let's see how many, there we get 6 and 6. We got 2 of the same number. Okay, so what this is doing is basically rolling 2 dice. Each value is random. The random value is a number between 1 and 6. It can be the same number. If you have 2 dice, you could roll a 6 and a 6. So replace equals true is this code here is equal to rolling 2 dice totally randomly. Okay, so let's say I have a list of students. Here's my list of students. And let's say I wanted to call one of these students randomly. Seems we have, 7, 8, 9, 10, 11. We have 11 students here. Let's say I wanted to call on a random student. How could I do that? I can use this sample function. Students is the data to sample from, to select from. And 1 means I'm only going to select 1 student. So here, it's going to select 1 student at random every time I hit enter. Next, let's say I wanted to select 2 students. I could say students equals 2. And I can run this. It's going to choose 2 students every time. Now, why don't I just write replace equals true? Well, if I have a classroom of 11 students and I want 2 students to be selected to come on the board and write something on the board, well, I can't select the same student twice, so I wouldn't want to replace that. So by default, replace equals false, meaning it's going to select 2 different students each time. Let's say that I want to select a student at random, and that student is going to get an automatic A on the next test. So I run this code here. I sample students 1. This student, Elisa, is going to get an A on the next test. They don't even have to come to class. Now, what would happen? Other students might get angry because, well, they don't know if it's random. Maybe I just ran this code as many times until a specific student came up. It's still random, but other people cannot get the same result because if it's random to you and random to me, our results are not going to be matching. Okay, so to solve this problem, we have something called set seed. We can set the seed to a number. What this number means is that the random algorithm inside your computer is going to be the same random algorithm for another computer if they're running the same code. In other words, what this means is, if I set the seed, and then I run this code, I get Tracy Farnaz. If I run it again, I'll get Ocean and Aya. If I go back and I set the seed again, and then I run my code again, I'm going to get Tracy Farnaz, Ocean, Aya. Now I'm going to go back and set the seed again to 1, then run the same code again, Tracy, Ocean. In other words, it's random, but the randomness is the same every time. What does this mean? It means that if you want something random on your computer and you want me to see the same result, or if you're working in a group with other students or on a project for a company or with any kind of research, then you want the results to be the same. You want the same matching results so that you can compare. In order to do that, anytime we use something random, we should set the seed. It doesn't matter what number you set the seed to. Let's change the number to 2. So let's start over. I'm going to set the seed to 2 and then run, select 2 students, Christina, Lala. Let's run it again. Lala, Patricia. Let's go back, set the seed to 2 again. We'll run our code one more time. We get Christina, Lala. If I run it again, I'll get Lala, Patricia. You get the same repeating sequence of randomness. So if your seed is set to 2 and my seed is set to 2, we're going to get the same result. If your seed is set to 1 and mine is set to 2, we're going to get different results. Okay, so setting the seed allows us to get predictable random results. Okay, so let's say we're rolling a dice. In this case, we're rolling a dice and choosing 2 numbers from that. If I set the seed to 1, run my code. If I set the seed every time I run this random code, I'm going to get the same result every time. If I change that number, I'm going to get a different random result, but every time I run that code, I'm going to get the same different random result. Okay? All right. So repeat. Repeat will repeat the same result n times. So let's say, for example, I wanted to simulate rolling a dice, or rolling 2 dice, right? This sample, 1 to 6, 2 replace true. This is equal to rolling 2 dice. So if I wanted to simulate rolling 2 dice 10 times, could I use this repeat function and repeat this function 10 times? What you're going to have is the same result 10 times. It's giving me 5, 1, 10 times. So it's not actually running the function 10 times, it's running the function once and printing the results 10 times. However, if we use a function called replicate, that allows us to replicate 10 times this function. So let's see what happens if I run this code. We get 10 by 2 matrix. What this is it's saying the first time we ran the formula, it's saying the first time we ran the function, we got 4 and 5. The second time we ran the function, we got 1 and 2. The third time we got 3 and 1, and so on. So if we want to simulate doing something many times randomly, we can use a function called replicate to do that. Let's talk about loops very briefly. A loop is going to loop over a set of values, in this case 1 to 10, for a variable, in this case I, and then it's going to run a block of code, a script of code, for every value of our iterable object. Now, that's a lot of words, so let's see what we get. So here's what we call an iterable object. In other words, we can iterate over this. It's a vector, so iterate means we can repeat over it 1 by 1 by 1 by 1, right? So in this case, we're going to iterate over these values 1 to 10. What's going to be iterated? In this case, it's going to be the variable I. The variable I is going to first be the number 1. When the value is 1, it's going to run our code, print I. What does print do? Print will print the result in the console. What is I? Well, I would be 1. Then, after it finishes the code in the bracket, in the braces, it's going to repeat that code for the next value in our vector, in our iterable object. Okay, so what happens if we run this code here? It's going to run the line of code print I for every value of I in 1 to 10. So what does that mean? For I in 1 to 10, print I. It's going to print I for every value from 1 to 10. So it's printing 1, then it's finished printing 1, then I becomes 2, it prints 2, then I becomes 3, it prints 3, and so on. Let's look at a different example. In this example, we have I, same as before. We're printing I, same as before, but this time my iterable object is different. In this case, my vector is the string values. Ian is awesome. There's 3 values, right? So I is going to be Ian, then it's going to print Ian. Is, print is. Awesome, print awesome, and then it's finished. It finished all of the values in my vector, and it finishes the loop. So that's what's going on with a loop. Let's look at a little bit more complicated example. In this case, I have for I in sample 1 student is also awesome. Okay, so who's students? Students is that list of students. It's going to sample 1 at random. Every time it's going to be different. So if I say I in sample a student, it's going to be a random student is going to be put into this vector. Okay, so every time I run this code, it's going to be a different student's name. The next example is a while loop. These are a bit less useful for statistics, so I'm not going to spend very much time on this one, but I just want to show you what it looks like. I is going to be a value. First I is 10. So while I is greater than 5, right now I is 10, run this code. Here's the code. So first it's going to run, I is 10, so 10 minus 1 is 9. So I is now 9. Then A is A plus 1, A. Then it's going to print A and I. Okay, so what is the value of I now? Well, I is now 10 minus 1, so it's 9. So while 9 is more than 5, is that true? Yes, it's going to run. It's going to keep running until I is not more than 5. Okay, so here's what that would look like. There we go. So we're printing A and I. So here's A, here's I. So the first time I became 9, A became 1, and so on until I is not greater than 5. A conditional statement means do something if it's true, if it's false, do something else. The most basic is just an if statement. In an if statement, it means if the statement is true, do the next line of code. If the statement is not true, don't run the next line of code. All right, so let's say B equals 1. If B is more than 50, run B is more than 50. Is B more than 50? No, B is 1, so this is not more than 50. So if I run this line of code, I get no output. If I change B and we make B 100, run our line. Now what's going to happen if I run this code? If B is more than 50, is it? Yes. So what's going to happen? It's going to run B is more than 50. It's going to print B is more than 50. So then we get B is more than 50. All right. An if-else statement means here's our condition. Our condition is either true or false. If it's true, do the first part. If it's false, do the second part of the function. Okay, so let's run this code. What is the value of B? Well, it's 100, right? We made B 100, so if B is 100, what's going to happen if I run this code? As I said, if our condition is true, run the first part of the code. If our condition is false, run the second part of the code. Is it true or false? It's true, so it's going to run the first part of the code, which is just to print B is more than 50. So we get B is more than 50. Let's change B back to 1. Let's run our code again. What's going to happen? We'll get the second part. B is less than or equal to 50 because our condition was not true. All right, so our next if-else statement is here. If our color is red, color is an object, a variable name. Equal means it's equal to that. It's the same as using this arrow. Okay, so we're assigning the value red to color. And now we see a new operator. What does this operator mean? Before we saw a greater than and a less than symbol. Now we're looking at a symbol that says equals. This means if this value is truly equal to this value, then it's true. If not, then it's false. So what is our color? Our color is, What is our color? Well, let's assign a value to color. So now what is color? Red. The character string red. So if I said color equals blue, is this true or false? The result is false because color is red. Is red equal to blue? No. So what happens if I run this code? If our condition is true, it does the first part. If our condition is false, it does the second part of our code. Is our condition true or false? It's false, so it's going to run the second part of our code here. So let's run this and see what happens. Boom. We get it's not the best color. Why? Because our condition was false, so it's running the second part of our code, and the second part of our code says it's not the best color. Next, let's look at value selection. So A is going to be the values sequence -3, 3. This means it's the integers from -3 to 3. So -3, -2, -1, 0, 1, 2, 3. That's going to be our vector A, right? -3 to 3. If I said A3, what is this? Well, we have those square brackets again right here. What do square brackets mean? It means from our data, in this case our data is the vector A, give me value number 3. Give me the third value. Well, what's the third value? This is the first, this is the second, this is the third value. So let's see what we get. We get -1 because that is the third value. We're using an index and it's returning the value. The index means it's the first, second, third, or fourth or fifth value, right? This is the third value. That's our index number 3. The value is this, -1. All right. What does 3 ... 4? What does 3:4 do? Gives us all the values from 3 to 4, which are 3 and 4. That's it. So now this is called slicing. We're slicing from 3 to 4. What is the third and fourth value? Well, here's the first, here's the second, here's the third, and here's the fourth. So what are we going to get when we run this code? We're going to get -1 and 0. We're slicing values out of it and returning those values. Okay, finally, we have one more way that we can index from our object. Here's our vector A. A looks like this, right? C, what does C mean? It means we're using more than one value in one position, in one location. What values do we want? 3 and 4. Okay, that's going to give us the same values. Now, what if I added a different value? Or what if I put them in a different order? What if I said 4, 3? Then that's going to give me the fourth value first and the third value second. Okay. If I wanted to add more values, I could add a comma. Oops, there's no 0. I could add a comma like this, add more values to it. Okay, next, this is very useful for dealing with data frames. We will deal with some data frames in this course, but not many. So this which function will tell you the index number if we input the value number. So a, what is a? A is this vector here, -3, -2, -1. So which index is equal to a equals 3? In other words, when a is 3, what is the index number? Well, that would be 1, 2, 3, 4, 5, 6, 7. That's the 7th value of our vector. So 7 is the index number which a equals the value of 3. How about this one, A7? Well, this means I'm inputting the index. Anytime we use a square bracket, we're using an index to get the value. In other words, this which code is saying I'm inputting a value and the output is going to be the index. In my second code here, I'm inputting the index and the output is the value. Okay, so every value has an index, every index has a value. All right, so now what's going to happen here? Well, what is this? This one is what? Which a equals 3? As we said, this one's 7. So what happens if you say a index 7? You would get 3. So in other words, this code is the same as saying, well, what's the value of which a equals 3 is 7? The same as saying this. Well, what is the value of that? 3. Okay, so this is just doing the same thing. First, it's calculating which index, which is 7. Then it's just inputting that index into our indexing bracket, into our square bracket. Now, this one's not very useful, right? However, if we use which and a function like this, which a is more than 0, well, which one is a more than 0? What happens if we run this code one by one? Well, first let's run the code. We get 1, 2, 3. What is that? So let's run the code one by one. So first, let's look at the most inner part of the parentheses. We have square brackets here, then we have one more parentheses. So let's run this. R is running it one by one from the most inside parenthesis outward using that order of operation. So first, it's going to run a is greater than 0. What is this? This is a Boolean result. It means it's checking each value of a. We have -3, -2, -1, 0, 1, 2, 3. And it's saying which values are more than 0. Well, -3 is not, -2 is not. None of these values are more than 0, so we get false, 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 false. Then we have 1, 2, 3. These are true because they're more than 0, so we get true, true, true. So if we run this code here, we get false, 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 true, 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 which will give us the index 5, 6, and 7, meaning this is index number 5, index number 6, index number 7, which are more than 0. And then if I said, give me index 5, 6, and 7, that gives me the values 1, 2, and 3. Okay, so this is useful to check which values follow a specific condition. Okay. All right. It's also useful to organize our data. Let's make a new value of y. So in this code, we have an arrow. That means assign the values 0, -1, and 1. Then we have this semicolon. This means that it's a new line. It's a new code after it. It's the same as putting a new line here and running 2 lines of code. Okay. A shorter way to do it is to use that colon. That'll do the same thing. All right, so y is the value 0, -1, and 1. So if I sort y, what is the lowest number? -1 is the lowest number. Okay, so sorting y will put them in order from lowest to highest, -1, 0, 1. Order will give you the index number of the sorted values. So for example, so originally y is 0, -1, and 1. If we sort them, it's -1. It's just in the values in order. If we use order, we're looking at the index associated with the lowest value. So in other words, which value is lowest? -1. Which index is -1? That's the index number 2. That's the 1, 2. It's the second value is the lowest value. All right? The second lowest value is 0. What is the index of this value? 1, because it's the first value. So that's why in order we get 1. And 3 means 3 is the biggest number. 1, 2, 3. The index of this value is 3. So these are the index numbers, and sort is giving you the values in order. Again, order is giving you the indexes in order from lowest to biggest, and sort is giving you the values from lowest to biggest. Z are these numbers here. 3, 5, -1, 2, 2, 9, right? So what is the lowest value here? Well, it's this -1, right? What is the second lowest value? These 2's. All right, so what's going to happen if I sort my data? Well, it should sort the values from lowest to biggest, which are -1, 2, 3, 5, 9. That's the easy one. If I use this order function, what's it going to give me? It's going to give me the index numbers in order. So what is the lowest value here? Well, as we said, -1 is the lowest value. What index is that? That's index number 1, 2, 3, 3. So order Z should give me 3 as the first result. What's next? 4 and 5 in order from left to right. And then what? What's bigger than this? The first value. So we should get 3, 4, 5, 1, because the 3 is the next value. 2, because 5 is the next biggest value. And finally, 9, the last value. Okay, so what does that give us? That gives us 3, 4, 5, 1, 2, 6, just as we predicted. All right, so we've got one more very short section. All right, so we've got one more very short section of the basics of using R language. Okay, so in this case, I have x, which is a vector. What is my vector? It's these values here. What kind of data is this? What data class is this? This is a character class. Why? Because we have the quotation marks. Okay, so if we have quotation marks, it means we have a character data type, a string. We have y. What type of data is y? It's numeric. We have an integer. Finally, we have one more, which is A, B, C, C, D, which is another character data type because we have the quotation marks. Okay, so let's assign these. This code is just assigning each one of these, x, y, and z with a value, basically a vector of values, a string of values. Okay, all right. So the function called data.frame will create a data frame based on our data. Our data is x, y, z. All right, so what does our data frame look like? Looks like this. X was these numbers, right? January 1st, January 2nd, January 3rd, January 4th, January 5th. And what we have is, when we change it into a data frame, x, z, y, these are the order that I put them into my data frame, x, z, y, and it creates the data frame column-wise, meaning each one of these vectors becomes a column. Okay? Then we also have one more thing. We have our column names on top, and we have our row names on the left side here. 1, 2, 3, 4, 5. Each row name needs to be unique in R. Right? All right, so here is what our data looks like. So a data frame is a really good way to save a data set. Data set, you can think of it like a two-dimensional table. Basically, anytime you use Excel, you're creating a table or a two-dimensional object, a two-dimensional array. All right? So data frames are really useful for this because they can keep track of different variables. In this case, data $x means from our data frame, give me only the column named X. The $ is used to indicate you want only one variable. You want only one column from your data frame. Okay, let's run this. We should get X, which is the dates. Okay, there we go. It became a vector. We can do the same thing with Y. We can do the same thing with Z. Another way to get the same information is to do it like this, but we're doing it by saying, from our data frame, give us all the rows, comma, give us the column called X. Here, we're saying give us all the rows. It's blank before the comma. Before the comma is rows. After the comma is columns. So basically what this is saying is just give me the column X, Y, or Z. All right, so if that's how we can access a column, what if we wanted to change the column into a different data type? Now that first data type, data X, is a string, is a character class. So here if I write class data X, it tells us that it's character type. If I want to change that, I can use the function asDate, and this will change it into a date type. So I'm going to use this function here to change my data X into a date, and then it's going to update the value of that column. So now, if I say, what is the class of data X? It's now a date. Why? Because, remembering the order of operations, the assignment operator is always last. So what happens first? It changes our vector into a date, and then it saves that vector over the old vector called data $X. So now we have an updated value, which is now a date. The next variable, we have the same thing, but we're changing it into a number. The last one we're changing into a factor. What is a factor? A factor means we have categories. In this case, we have the categories A, B, C, and D. These are the values. These are the possible categories on the bottom. Levels means the possible categories. On top, these are the values that we actually have in our data. All right, so let's use a function called structure, STR for structure. This will tell you the structure of your data frame. Here we go. It's telling us that we have 5 observations, we have 5 rows, and we have 3 variables, we have 3 columns. $ means a column, so column named X is a date, and in that date format, here's the first few examples. Here's the first example, here's the second example, ... There's a lot of others. The next column, column Z, is a factor with 4 levels. That means it's a categories with 4 categories. There's 4 groups. And it names what the groups are, A, B, C, or D. These are the groups. And these are the values that we have. The first value is 1, meaning that it's in group 1, A. The second value is 2, meaning it's group 2, which is B. The next one is group 3, which is C. The next one is also group 3, which is C. The last one is group number 4, which is D. Okay, and finally, Y is numeric, meaning it's a number, and these are the numbers. Okay, all right. We can use summary. This is the last function we're going to talk about. And what does summary do? It gives you a summary from the minimum to the maximum. Because these are dates, it knows that the first date is the earliest, the last date is the latest. Z is categories. If we use summary on categories, what it does is it tells us how many are in each group. So there's 1 in the A group, there's 1 in the B group, there's 2 in the C group, and there's 1 in the D group. That's what this one's telling us. Finally, Y is giving us that same vector 5-number summary plus the average plus the mean. So we get the minimum, the first quartile, the median, the mean, the third quartile, and the maximum. All right, so I know this is a lot to process. However, not all of these codes are very useful for this course. I wanted to give a deep understanding of the basics of R. There's many other videos that are much longer that can explain these in much more detail. This is kind of a summary of the important things to get you started. However, you don't need to understand all of this lecture to understand how to use statistics and how to use R. All right, so thank you, see you in the next video, and thank you for watching. Let's say that I write a code and I randomly select a student to do some extra credit assignment. That doesn't make sense. Okay. My eyes are so red.